Today we are going to be making this Lego RBD destruction effect. Basically, go to this website, type in Star Wars for example, but you don't necessarily have to do Star Wars, you can really do anything on this website, but I'm gonna pick this one, say, and pick whatever you want, go to editor, and once it's loaded into the editor, we're gonna export it out as a DAE. Once you've got it here, you want to just go to file and export, make sure it's DAE, group by geometry, none, and then logos on studs. Basically just makes the model way more dense, so you don't really have to do that if you don't want to. I'm not going to do it for this tutorial. By the way, on mechabricks.com you're going to have to create an account to export. Hopefully you've got the DAE folder, so if you want to go to import Collider and just pick your folder out, I've already got mine ready to bring in. Tick off cameras, joints, lights, animation, keep geometry and materials, scale to Houdini unit length, and make sure to tick off lock geometry, and then just click merge. And that'll bring in your Lego model. Okay, so now go to Object, Network, Geo, drop down that Geo node, now drop down a for loop with feedback. On iterations, type in the code OPN, children, speech marks, dot dot, slash dot dot, slash Collider scene, visual scene, speech marks, and then okay. Drop a merge node between the two nodes you already have down. Drop an object merge node down. Go to this little icon here. Go to Collider scene, visual scene, part 0, file, accept, and then bring that into the merge. Make sure to change the transform into this object and rearrange the merge node appropriately. Then on repeat begin, create import node. Drag that to the left side. On object merge node, replace the 0 with 2 backticks. Now between the backticks, put detail -1, comma, speech mark, iteration, speech mark, comma, 0, close it off, enter. Now it's gonna freak out, but to deal with that, go to this little cog thing here and add spare input, scroll down, this little icon here, go down and click metadata and accept that. Once it's cooked, unless you want to escape and cancel the cook, on repeat end, click single pass. Now drop down a name node between the object merge and merge node. On the name, piece underscore, then go to object merge again, everything inside the backticks, control or command C, go back to name node and just paste it in there. Now it'll probably freak out again, so go to this cog, add spare input and metadata node and accept that. Now drop a color node after that node, add a spare input, meta node again, metadata node, accept. Now go to the OBJ network, Collider scene, shaders, click L to lay it out, and in this shader here, diffuse, copy parameter, then go to obj, geo in the color node. Paste relative reference. Now go back to obj, collider scene again, visual scene though. Go to part 0, foil, on shader, copy parameter of this surface shader. Go to obj, geo, on the color node. Now go into this, space, paste relative reference, so there. You want to just copy, control or command copy that, cut it, and then replace all this with this. Now just do what I've done here, then go to object merge again, copy backticks again, command or control C, go to color, and where it says 0, place that with that. Remove the backticks and put pluses and speech marks. Then control or command C this whole code, paste it into this one, but on the second box where it says R, replace R with G representing green. Paste that in, put replace green with blue. So red, green and blue. And at the start of each piece of code, add an S after the second ch. Now let your for loop run and you'll be able to see the colors. Unhide the collider scene and there you have your colored Lego. Don't worry about these two little guys, we're gonna get rid of them soon enough if you have something like that. At this point I'd say drop down a foil cache node and save. Because if you've got a super big foil, it can be a pain to keep loading it in if you want to stop working on it. You just need the one frame really, so single frame, save to disk, and that should be good. And just make sure when you're file caching you can see this thing here. Now this foil is super big, so we're going to drop down a match size node and matching scale to fit. Make it viewable. It should be much smaller now. I'm selected. Much smaller, much better. Drop down a Tommy test geometry, which is basically just a human. So you can compare size. That's obviously way too big. So drop down a transform node. And maybe like 0.4. That's a lot better. I'd say that's probably pretty good. Now I'd say drop down a blast node. Also, thank you Tommy. But on the blast node, zoom in. Click this little icon here, drag, select. All these models, enter. And now if you look at the blast, it should, yeah. So there is a bit of stuff there. So if you drop down now a clean node, should remove it. Tick off remove degenerate primitives. Drop down a fuse node. Bring that down a bit. Add an attribute promote before the fuse node. Change the original class from point to primitive and type name into original name and tick off delete original. Now look at the fuse node, tick on match attribute. Now drop down an attribute delete node and in point attributes type in name. Drop down a poly reduce node, so this will make our simulation faster, from 100 to 50. Then drop down an exploded view. So that you can see if there's any irregularities in your model, which there appears to be none in mine, which is great, and hopefully there's none in yours. Drop down a null, and now this is, we're going to name this as high res. I'm going to just connect that up. Now we're going to start working on the glue. So now drop down an RBD constraints from rules there. Connect that to the poly reduce. And on connection type surface points. Make that viewable. Then max connection, scroll down to constraints per piece. To constraints from piece 2. Max search points 50 and on search radius 0.002. Sorry, 0.02. Then drop down on RBD constraint properties. Set the glue strength. Connect each one, by the way. And set the glue strength to 10. And propagation iteration to 8. Drop down an RBD configure node. And scroll down to here, density, tick on user density. Now drop down on RBD pack. Plug the high res null into the first input. Second input to the second input. And then the first input into the third input. Then drop down a transform node, and now you're going to place your model to where you would like the animation to start. So I'd say like maybe like that, and then give it a little rotate maybe. Okay. Now drop down on RBD unpack. Then go up to here, alt click, or option click if you're a Mac, and take this high res, bring it down here, plug that into there. Then drop down on attribute adjust vector. Plug that into the third input. Set the values for now as -1 on the Y because we want it to go down, and then 0.4 on the Z for a bit of irregularity. Then turn on this little visualizer here. Drop down on add node. Plug that into there. Then on the add node, delete geometry but keep the points, and now if you zoom in here, you can see the trail from where the ship is getting velocity from, so pretty much it's like straight up, which might not be how you want yours to go. Like I'm kind of thinking that I want the ship to go that way, so maybe I have the velocity coming there. So for me, I'm gonna have to adjust it appropriately, so maybe like -4 on the X. So once you've adjusted the attribute adjust vector appropriately, so you have these trails flowing backwards like this, these are the settings I used. Then you're gonna want to add another attribute adjustment vector. Connect that to the, or change the V to a W, and then set the Y value, no, the Z value to like 20, and this gives it like an irregular spin, which makes it a bit more realistic. Angular velocity to be specific. Now for the final simulation, so drop down a .NET. So put the attribute adjust vector 2 into the first input, put the RBD unpack second input into this second input, dive into the .NET, drop an RBD packed object, and drop a rigid body solver. Plug the RBD packed object into the first input of the rigid body solver. Drop down a gravity node. Add a ground plane. Connect the rigid body solver to gravity and the gravity to the output. Drop down a merge node. Pull it between rigid body solver and gravity. Plug the rigid body solver into merge and the ground plane. Put that upwards on ground plane. Tick off display proxy geometry. Put down a constraint network. Like that. Then put down a glue constraint relationship and plug the green into the green. Set all the inputs on the glue to 1. Change the name to just glue, so just remove that. On constraint network, remove keyframe, set it to 0. geometry source as second context geometry. On the RBD packed object, set as fast context geometry. Scroll down and there should be, yeah, inherit velocity from point velocity. Tick off display geometry, go to bullet data, show guide geometry, and this is not correct, so we'd want to go to collision padding, set it to 0.0075, and that's a more accurate representation of our geometry. And then just turn off show guide geometry, turn on display geometry, come out of .NET, not outside of the geo, on the .NET, simulation, substeps, say 2, but you should go for free if you're rendering. On the object merge tab here, object, RBD, then that, asterisk, and then play it out. It should just work, and you can adjust the simulation by adjusting the attribute adjust vector there. So for me and possibly for you, I would say that you should go to RBD constraint properties and change the strength from 10 to maybe like 5. You can change the strength of the glue, so I feel like 1 works better for me. And that is the tutorial.